Welcome to ecology video number 6, and our topic today is human population, which correlates to section 4.2 in your book. In this podcast, we will explore the trends in human population growth. We will compare age structure diagrams of non-growing, slowly growing, and rapidly growing countries. And we will also predict the consequences of continued population growth. To begin our study of human population, we have a new vocabulary word, demography. Demography is the study of human population, the human population size, density, distribution, movement, and birth and death rates. Demography, the word origin comes from the prefix demo, comes from demos, which is a Greek prefix for people. So again, demography is the study of people and human populations and all that goes along with that. In this diagram, we are looking at human population growth, starting at the year 1 AD and projecting all the way to 2075. So you can see, and this is in billions of people. So from 1 AD to 1600, there's a real lag phase or a low amount of human population. The reason for that being is they had high amount of birth rates, but they also experienced a high amount of death rates. But around the 1800s, with the Industrial Revolution, we have a lot of technological advances that put the human population then on an exponential trajectory, and we are currently at here in 2013 approximately 7 billion people. So we're currently at 7 billion people. As we saw in that graph, for thousands of years the environmental conditions kept the size of human population at a relatively constant number below the environment's carrying capacity. But technological advances have allowed humans to alter our environment to increase our carrying capacity. One of those technological advances is agriculture. Agriculture advancement and the domestication of animals have increased the human food supply. Another technological advancement was advancement in medicine. Medicine improved the chance of human survival by reducing the number of deaths due to disease and parasites. Just our awareness of germs and creating vaccines to eliminate plagues and whatnot. And improvements in shelter have made humans less vulnerable to climatic impact due to our ability to heat and cool ourselves. Although human population continues to climb exponentially, our growth rate is actually slowing or declining. Our growth rate reached a peak in 1962 at 2.2 or slightly above 2.2. And our current growth rate is approximately 1.1%. So again, even though human population continues to rise, our growth rate is actually slowing or declining, and that is due to voluntary family planning, again, people having less children. Human population growth is not the same in all countries. It can vary due to several factors, but disease and war being two examples. So let's look at a few countries to compare their population growth rates. And we will start with the United States in orange. The United States has a 0.92 population growth rate percent. What that number means is that for every 1,000 people in the United States, there are 14 births and 8 deaths. So again, 14 births and 8 deaths per 1,000 people gives us a 0.92% population growth rate. A slow but positive growth rate. Now let's turn our attention to Honduras. Honduras is a yellow country in South America, and Honduras's growth rate is 2.16. 2.16. So per 1,000 people in Honduras, they have 30 births compared to only 7 deaths. So 30 births compared to only 7 deaths per 1,000 people gives them a 2.16% growth rate. And that is, again, a lot more births compared to deaths, so that is a growing population. On the other hand, we can have a negative population. If you look at Bulgaria, Bulgaria is a dark green country near Europe, near Germany, and they have a negative 0.89% population growth. What that means is they are having less births compared to their deaths. So, yes, so they're experiencing a negative population growth. We just looked at a positive growth rate, and we looked at a negative growth rate, and we could also have a zero population growth. The zero population growth occurs when the birth rate is equal to the death rate. And now we're going to turn our attention to age structure graphs, which are going to look at numbers of pre-reproductive individuals, reproductive individuals, and post-reproductive individuals. And at a zero population growth, all 3 of those stages are approximately equal. These are age structure graphs. Age structure graphs show us the number of males and females in 3 age groups. The 3 age groups are a pre-reproductive stage, which is 0 to 20 years old, which we know you can be reproductive before age 20, but this is just how it's defined on the age structure graph. And our reproductive age or stage is 20 to 44 years, and post-reproductive stage is 44 years plus. So let's start with the first one. Kenya has a rapid population growth. So look at the base of their graph. The pre-reproductive age from 0 to 20. They have a large amount of individuals in the pre-reproductive stage. So again, it's showing us males. There's about 9% of males 0 to 4 years old, and about 9% of females 0 to 4 years old. And so you can see they have a lot of young individuals. So this is going to be a rapid growth country because they have so many individuals in a pre-reproductive age that are going to grow up and become reproductive, that their population is going to continue to grow. And you might notice that their post-reproductive age group, it really declines. They are a developing country, and due to disease and other factors, many of their individuals do not live long lives. Now let's look at the United States in the middle there. The United States is a slow growth country, so you can see we have a little more individuals in the pre-reproductive and reproductive ages than we do older. So we are still having a positive growth rate, but again, it's not as dramatic as what is happening in Kenya. And then Germany, our third graph here, was similar to Bulgaria in that they are experiencing in this graph a negative growth. So they have less individuals in the pre-reproductive stage. So because there's less births, they have a lower growth rate because those in the pre-reproductive age, as they grow up, there are less of them to have children. In summary, a positive population growth has more people in the pre-reproductive and reproductive stages, and they have a broad base in that diagram, and less old people. A zero population growth would have an equal amount in all three stages. A zero population would have an equal amount in all three stages. And a negative population growth has more old people and less young people. Like all populations, humans have a carrying capacity. Our carrying capacity is dependent upon abiotic factors, biotic factors, and our technological advancements. All the resources humans need, such as food, water, fossil fuels, they require space to grow, to mine, and that space may become our limiting factor. We discussed the change in human population, where at the industrial age our human population is exponentially growing. Although we're exponentially growing, our growth rate has declined due to family planning. Human population growth rate is different in different countries, and that is dependent upon births, deaths, immigration, and emigration. And the human carrying capacity is dependent upon abiotic, biotic, and technological factors. I hope you enjoyed this podcast on human population.